There's a technology out there that's so powerful it could literally reshape our entire world. But, and this is a big but, it's also kicking off this incredibly fierce global competition. Today, we're going to dig into something called the quantum divide. And this isn't just some fringe idea. It starts with a really stark warning. A group of quantum scientists, the people who actually know this stuff inside and out, they just published a manifesto. And their message? It was crystal clear. They're seeing parallels between the quantum race happening right now and the nuclear age. Yeah, the nuclear age. That alone should make all of us sit up and pay attention. So, okay, the nuclear age. Is that a fair comparison? Is it over the top? Well, to figure that out, we've got to look at how quantum science is making this huge leap, from the quiet research lab right onto the battlefield. This isn't just about weird physics theories anymore. We're talking about a fundamental shift in how entire countries think about power and security. And the key idea here, the term you're going to hear a lot, is quantum militarization. So what does that mean? It's basically the moment when this technology stops being just a curiosity for physicists in a lab and becomes a core piece of a country's entire strategy. We're talking economic power, defense, and geopolitical competition. It is a total game changer. And this whole militarization thing, it creates this massive tension. Because, well, quantum technology is the definition of a double-edged sword. It has this incredible, almost utopian promise for humanity. But at the same time, it carries some seriously immense peril. And you can see that contrast, like black and white, right here. On one side, you've got the incredible promise. Imagine discovering life-saving drugs in a fraction of the time, creating super advanced materials and batteries, maybe even solving climate change. But the exact same science, the very same principles, they power the other side, the peril. We're talking about things like interception-proof communications for the military, quantum radar that can spot stealth planes, and whole new arenas of cyber warfare. It's literally two sides of the same quantum coin. So, with stakes that high, is it any surprise that a massive global race has already kicked off? Of course not. And if you really want to get a sense of just how intense this race is, you just have to follow the money and the patents. Get ready for this number. $55 billion. That's how much money governments around the world have publicly poured into quantum tech just since 2013. This is not some small-scale research grant. This is a full-blown national priority on a massive scale. And this chart, it shows you exactly where all that investment is going. Just look at the patent filings. China is way out in front with almost half of all global filings. The United States comes in next. So it's becoming really, really clear that the whole innovation landscape is getting super concentrated with just a few major players. And this didn't just happen overnight. This concentration of patents is the result of an absolute explosion in innovation. If you look at this timeline, you can see it. The number of international patent filings has skyrocketed. We're talking a 5-fold increase in just the last 10 years. The pace is just picking up like crazy. So what happens when you have all this intense competition? Well, nations start to put up walls. We're seeing this major push towards something called quantum sovereignty. And what that really means is this idea that a country has to have total control over its own quantum technology, from the very first design to the final deployment. And that, of course, leads to things like export controls, basically deciding who gets access to this incredibly powerful tech and who doesn't. And when you start building these kinds of technological walls, you create a huge problem. A great quantum divide is starting to open up right across the globe. And the big question is who's being left behind. Now, this is super important. The quantum divide isn't like the digital divide we've been talking about for decades. See, with quantum, the advantage for the haves scales exponentially. That means the gap doesn't just get a little bigger over time. It widens at this mind-boggling rate, making it pretty much impossible for anyone else to ever catch up. This chart really just lays it all out in the starkest terms possible. On one side, you've got this tiny group of nations pouring billions into their quantum strategies. And on the other side, over 150 countries with no formal strategy at all. They are, for all intents and purposes, being left on the sidelines of what could be the biggest revolution of our time. So why should we care? Why does this matter? Well, for the countries on the wrong side of that divide, the consequences are pretty severe. We're talking about becoming totally dependent on other nations for your most critical infrastructure, losing control over your own country's data and encryption, and basically being shut out of the next huge wave of scientific and economic progress. It's a huge deal. Okay, so all of this, the insane competition, the billions of dollars, this widening divide, it leaves us standing at a really critical crossroads. And the choices we all make right now are going to lead to one of two very, very different futures. So, path number one, we can call it algorithmic dominance. In this future, quantum technology is locked up inside these tight competitive blocks. A few powerful countries get to set all the rules, and they get to reap almost all the rewards, while everybody else just falls further behind. But then there's the other path, shared progress. Think about something like CERN for particle physics, a model based on shared labs, open standards, and a focus on using this amazing technology to solve big global challenges together. And that really brings us to the fundamental question we have to ask ourselves. A certain amount of competition between countries, it's probably inevitable, right? But does that competition have to end in total technological isolation? Is there a way for us to compete but still cooperate where it matters most? Because in the end, it really all boils down to this powerful idea: physics. That's what determines what quantum systems are capable of. But it's us, it's our governance, our policies, our willingness to work together that will decide who actually benefits from it all. And that's the choice that's staring us right in the face.